Hello, my name is Sudesh Sigobe. Join me as I shall be explaining to you all integration by substitution. Of course, if you like the channel, please feel free to like and subscribe. Alright, so integration by substitution. So there are some prior knowledge that we must know beforehand, before we begin this topic. Alright, first of all, you must actually know how to integrate. Alright, that is all the rules of integration. Secondly, you must know all the rules of indices. And you must know how to differentiate. Further that, expansion of brackets. So this is why this topic represents one of the crowning jewels of maths, which is taught this in the upper school years of a secondary school. Alright, it is also taught within the calculus courses as well. Alright, in the calculus courses, this is taught as well. Alright, so it requires a lot of prior knowledge. Alright, it's not one that should be taken very lightly. Alright, so moving on, we shall do this through a worked example. Suppose we are asked to integrate x multiplied by x plus 2 raised to the power 15 dx. Do we necessarily have to use the binomial theorem here and expand x plus 2 raised to the power 15? Or a more crude and a more brutal way of doing this, do we expand x plus 2 15 times? Isn't here a smarter and easier way to do the same operation? And the simple answer is yes. Alright, so in order to do this, we employ a technique called integration by substitution. Integration by substitution allows us to do the same task in fewer steps, thereby ensuring that we work smarter. So what is this integration by substitution that we can employ across here? Okay, let's explore this a little bit. Let's explore this further. So the challenge here is to actually expand this x plus 2 raised to the power 15. Alright, but we are trying to avoid having to expand this out. So one idea is to let u equal to x plus 2. So u becomes a dummy variable here. Alright, becomes a dummy variable. And this is where the substitution begins. Alright, that u equals to x plus 2. So whenever I see x plus 2, we're going to replace with u. Alright, next thing. So you see this x plus 2 becomes u. Alright, next thing. Du dx is really 1. So here it is, we assume you know how to differentiate. Alright, if you have a very weak knowledge of differentiation, you're going to have trouble with this topic. So please make time to revise and review differentiation before we engage into this topic. Alright, so if du dx is equal to 1, guess what? If we transpose this, we get du is equal to dx. Further to this, if we transpose again, you see u is equal to x plus 2. If you make x a subject of the formula, guess what? You get u minus 2, which is what I have done here. X is equal to u minus 2. Alright, so let's try and substitute and let's see what happens into this. Alright, so with all this information now, we are actually going to make this substitution inside of here. Alright, this is what I've written here on the left. Alright, so x dx is ready becomes du. See that? Dx is really equal to du. Alright, so there are some steps involved. Alright, so you need to change everything in terms of the u, the dummy variable. Now this is, we can actually expand this and integrate. This becomes much easier to integrate. So there's no need to expand x plus 2 15 times. Alright, there is a smarter way to do the same job. Alright, so expanding this becomes u raised to the power 16 minus 2u raised to the power 15 du. Alright, this is much easier to integrate. When you integrate this, you get u raised to the power 17 on 17 minus u raised to the power 16 on 8 plus c. Alright, remember we have no limits here. See, there are no limits here and here. Okay, so we just put the general constant of integration. Alright, if we had limits on the other hand, then this c would actually disappear. Alright, so we see in here that we are actually doing integration by substitution without limits. And yes, integration by substitution with limits can also be done. Alright, I shall explain this further in another video. Okay, so we have integrated and we end up with our expression here in terms of u. Now remember, u was a dummy variable, so whenever you see u, you have to replace with x plus 2. Alright, so x plus 2 raised to the power 17 on 17 minus x plus 2 raised to the power 16 on 8 plus c. And this represents your final answer. Alright, so what did we start off with? So we started off with integral of x times x plus 2 raised to the power 15 dx. And we have arrived at an answer here. Right, which is x plus 2 raised to the power 17 on 17 minus x plus 2 raised to the power 16 on 8 plus c. So there is no need to go ahead and expand 15 times. Alright, unless you are absolutely bored. Alright, and there are smarter ways of doing the same thing. So integration by substitution was really created as a tool, as a technique to make the integration much easier. Alright, thanks for listening. If you like this video, please leave a like and subscribe. Okay, thanks again. Have a nice day. God bless and take care.